Hello, Coach Holmes here, and today we're going to be talking about midpoint and segment bisectors, okay? We're going to be talking about the midpoint and segment bisectors, all right? So, first off, what is a midpoint exactly? Well, the midpoint is a point, is a point that divides the segment into two congruent segments. So basically, it's being able to cut a segment in half. That's initially what a midpoint is. If you cut a segment in half, whatever that halfway point is, that's a midpoint. It's basically the halfway point. Now, a segment bisector, that's a little bit interesting. Okay? It's a point, ray, line segment, or plane that intersects the segment at the midpoint. So initially, whatever we considered the midpoint, that's the midpoint, that's a segment bisector. So basically, it could possibly be a point, a ray, a line, or a plane. It can be any of those things. Whatever we use it for to make a midpoint, that's a segment bisector. So here's one example. So you see this sample segment AB, point M here, this point is a segment bisector. So we got a point as a segment bisector. Now I want you to notice these real quick, and you don't have to write this, you don't have to circle these. But what this tells you is that these are the same distance. You may want to, I know I said you don't have to write this down, but it'd probably be good. So if you have a dash like this, it tells you that these two are the same distance, because remember, if we cut something in half, we're talking about two equal parts, okay? So since this point cut the segment in half, AM and BM are the same distance. And in order for us to know that, we put a little dash line in between, we put the dash line between the 2 points. So that way we know that they're initially the same. Now if we look at segment CD, now its segment bisector is actually a ray from point M. Now notice that the two dash, same distance. That tells us it's the same distance. We also have segment EF, and this time it has a line through point M telling us that the segment bisector for this is actually the line. And again, the two dashes, that tells us it's the same distance. And then lastly, we have the segment GH with a bisector as the segment bisector as the plane. Normally, you're not going to see this very often, but I'm showing you this as a good possibility that you might see, or there is such a thing as a segment bisector that is a plane. But 99% of the time, you're not going to see this. So I wouldn't worry too much about seeing this, but I do want to show y'all this because this is a good possibility. Okay? So those are our segments, okay? Those are segment bisectors that we just saw. And I want you to just remember that segment bisectors could be points, rays, lines, or even planes. Okay? It can be any of those things. Now, as far as finding distance using the midpoint, we should be able to find it pretty easily. So for example, I got a segment PQ, and I got midpoint M with a segment bisector ray MR. Now, I want to find PQ. I want to find that distance. Well, first off, I know that PM is 2 4/5. So, if I know that these two are the same, then I know that MQ is 2 4/5. Excuse me. So I can add these two together. 2 4/5 plus, excuse me, 2 4/5. It's going to give me 4 8/5. But we can't say that. So we're going to change that to 5 3/5. Because I have 5 left, because if I take 5 away from 8, I have 3 left over. So that's going to be 3/5. 5 with 5 is 1. So I just make the 4 bigger than 1 by 1. So 4 3/5. And that's what PQ is going to be. Okay? Now let's look at the next one. So now let's say I want to find the distance of PQ and PM. I want to find those two distances. Well, first off, I know that if this is my midpoint right here, which by the way, midpoint typically is going to be labeled as a point M more often than not. So since I now have a midpoint M, I know that these two has to be the same. So I'm going to set them equal to each other. So I have 3x minus 4 equals 2x plus 1. So I'm going to add, so now I got variables on both sides. So I'm going to add 4 to both sides. That's going to leave, this cancels out, so that leaves me with 3x equals 2x plus 1 plus 4 is 5. Next, I got to get rid of this 2x. So I'm going to subtract 2x from both sides. And that leaves me with 1x equals 5. Now, PM is not 5. What this tells me is that the value of x is actually equal to 5. So, I gotta replace because I know that PM is equal to 3x minus 4. But what I can do, I can replace the x with 5. So let me do. I'm going to replace x with 5. So I have 3 times 5, which is 15, minus 4. 15 minus 4 is 11. So PM equals 11. Now remember, PQ is just cut in half. So if I know 1/2 is 11, I can double this to give me 22. So the distance of PQ is 22 units. And the distance of PM is 11. So the biggest thing we just got to remember is that when it comes to midpoint, it's basically telling us what's halfway. It's telling us the halfway point of a segment. And just remember, when we're talking about halfway, we're talking about two parts that are equal distance to each other. Okay? So just remember, midpoint cuts it in half, and when we cut it in half, it's two equal parts. So, thank you, and have a good day.